Hello everyone, my name is George and I'm a senior software engineer at Collabora. Today I am going to talk to you about video support in AGL, taking a look at the various use cases for having video in a car, looking at the requirements that these use cases have, and presenting potential software solutions from the viewpoint of AGL. Let's start by taking a look at the use cases. So in modern cars, the need for dealing with video is more and more growing. And some use cases have to do with using cameras. A popular feature, for example, is to have dashboard cameras, cameras that record what is in front of the car in the street. Or another popular feature is to install cameras at the back of the car and use it for rear view display, showing to the driver what is behind the car, useful when going in reverse. Another modern use case has to do with AI processing. So some cars install cameras to for example, monitor the driver's condition, or another use case is to install cameras to monitor the surroundings of the car and implement autonomous driving. Another use case has to do with displaying video. So of course, when capturing feed from the back of the car, we need to display it somewhere for the driver to be able to see it. This is currently done, for example, with mirrors that have this integrated display, rear view mirrors, or displays in the dashboard of the car. And then there is, of course, the use case of providing entertainment for the passengers. Some cars install, for example, rear seat displays that rear passengers can use to display video content. And then we have things that are going on in the background. So, for instance, recording video, maybe from the dashboard camera. That's the most common case, to record the video from the dashboard camera. Or another use case has to do with processing. As I said, some cars implement AI processing for autonomous driving or for monitoring the driver, and maybe other things. And another thing that is done with video is to stream it to the rear seats, for example, or stream it to the network, or stream it from the network to get video content from an external source. So let's take a look at the requirements. First of all, safety. We cannot implement anything that is not safe for the passengers. So that's the top priority. Then a very important issue in the context of the car is how to control all these video streams. Since we have many different components dealing with video, cameras, displays, processing nodes, and we also have streams going to or from the network. All of these need to be controlled centrally, and they need to be secured so that nothing malicious can happen. No malicious application can take control of something or do something that is not intended. And then we also need to deal with the fact that all processing must be done in real time. We are capturing live video, we are displaying live video, and we're processing live video. So anything we do, it must be able to be done in real time. And then we also need to make sure that we leverage the hardware appropriately for efficiency and for safety. We need to be able to use dedicated hardware for dedicated purposes, and we need to be able to split the work across nodes in the car. Finally, when it comes to entertainment, we need to be able to deal with digital rights management. We need to be able to use modules that decode DRM protected content in a safe way and respecting the DRM standards. So where does AGL fit in this? AGL is a software system that can be present in multiple places in the car, right? It implements the operating system of the various components, and it may be running in multiple CPUs, in multiple nodes at the same time, implementing different things in each one of them. So one of the things that it may implement is some central system management node. It may implement the entertainment system. It may implement software that runs on dedicated displays like the rear view mirror or the rear seat displays. It may implement software that runs on the cameras, and it's actually a very common thing for network cameras, not car cameras, but network security cameras, to be running Linux-based systems, and that would probably make sense also for cameras running in a car. And AGL may also be used in processing software, in implementing the nodes that process data and provide analysis of the video feeds, or to implement recording and things like that. So let's assume that we want to implement such a system with AGL. Let's take a look from the perspective of the system running AGL and look at what the apps have available beneath them to deal with video input, output, and processing. On the input and output side, well, right away applications can access devices that are directly connected to the CPU they are running on using Video for Linux, which is the standard Linux kernel API for dealing with video devices. And nowadays there is also another project called libcamera, which is trying to bring modern camera features into Linux, both in the kernel and in the user space. Something that Video for Linux is not able to deliver appropriately. Then we have network streams. So video content can be input or output from the in-car network or from the internet. And yeah, we have the standard network APIs to deal with that, or proprietary APIs in the case of proprietary networks or proprietary devices that do not follow the standards and do not use Video for Linux, although that's not recommended. And then for processing, we may have software processing components that take video feeds from the kernel and process them and output them somewhere else. Or we may have hardware video processing units that we access again through Video for Linux. Or we may have network components that we send the video to and we get some results back, or we don't get results back, we just send it and if something else happens there. And then for display, we have Wayland, the standard display API for displaying things in our local display. And then we may again be using the network, sending something for display to another node in the car. Or we may be using hardware display overlays, which may be done through Wayland or through some other APIs. I've seen some devices using, for example, Video for Linux devices for overlays or proprietary APIs, although that's all not so recommended nowadays. The standard approach is to integrate that with Wayland. As you can see, there's a lot going on in the system, and it becomes more and more complex when you start combining multiple nodes in the car. So you may have an application that requires the cooperation of multiple AGL and non-AGL systems, streaming video across multiple points in the car, from the camera to a processing unit to a display, for example. So when it comes to this, it starts becoming quite complex, and the need is to have a standard set of APIs and tools to deal with all of this. From the viewpoint of the application, the standard software to use for implementing multimedia software is GStreamer. GStreamer is the de facto open source industry standard for building multimedia software. It comes with a wide range of plugins for all kinds of input, output, and processing of all kinds of media, audio, video, and others. And it basically can bridge all of the APIs that I mentioned earlier. So it bridges Video for Linux, Sleep Camera, software processing components, Wayland, and proprietary APIs, and many other things that you may need in order to get the work done. So it basically makes the job easier for applications. It heavy lifts all the application level needs, leaving to the applications just to do just what they need to do and not deal with the multimedia data. And not to mention that it's highly extensible and customizable, so if something cannot be done at the moment, it's possible to extend it, add some plugins, and make it talk to your device or your software component. And from the viewpoint of the system, where we may have multiple applications trying to get access to a single device or trying to share content between them, or where we have remote streams coming and going to from the network, the solution for managing all of these streams is PipeWire. PipeWire can be described as a stream exchange framework that allows interconnecting applications and network nodes, allowing them to share devices and share streams in a secure way, and applying policy that secures what applications can and cannot do. PipeWire allows isolating applications from each other and from devices. It was actually built with containers in mind. So it was built to be able to make applications access a device securely without actually having direct access to the device. A device may be visible from one container and the application in another container, and it gets secure access through the PipeWire system. Or similarly, it can be done with applications in different containers sharing a stream from one application to the other. And this allows actually implementing more smaller applications, smaller and self-contained applications that do a small task each. So for example, you may want to have a system that captures video from a camera and then displays it in the screen and records it. And these are 3 separate functions that can be in different applications and actually in different containers, sharing the stream through PipeWire. PipeWire is also very efficient. It has low-level real-time processing capabilities, and it allows leveraging the hardware to its full extent by using hardware buffers. So it can make use of hardware buffers to pass a stream from one device to another through a series of applications that do something with the stream without actually copying the data to the CPU memory if not necessary. Now, PipeWire, you already know that PipeWire is currently used to implement the audio system in AGL. Actually, both PipeWire and GStreamer are used in audio. There are similarities with the audio system. Actually, it's essentially the same system. The principles are not different. The only thing that differs is the kind of data that exists in the buffers. In one case it's audio, in the other case it's video. Everything else stays the same. So input, processing, output in multiple streams, local streams, network streams, streams coming from the network, from the internet or going to the internet, things like that. And applying policy to all of those streams, this is all the same as with audio. So reusing the infrastructure that is currently in place for audio makes sense to implement a video system. But first, we need to define our goals. Suppose we want to do an AGL demo with some video features. Video is a very broad term. There's a lot of things that we can do with video. So the very first thing we need to do is define our goals, define what exactly we want to show and we want to support as a community. And also we need to narrow down the scope, what the features exactly will be and what the supported hardware will be, because it's very different to work, for example, with a desktop USB camera. It's very easy to work with in a demo, but it's very different than using an automotive grade network camera. Next thing, we need to implement a demo application and add some features that are currently missing from PipeWire and WirePlumber. Both PipeWire and WirePlumber have been designed for being able to deal with the video data. And with all these use cases that I mentioned today, they have all been integrated in the design of PipeWire and WirePlumber. The thing is, of course, that not all of it is implemented. We currently support video on the desktop. So on the desktop, we can do sharing of cameras with video for Linux that is captured through video for Linux from the system and then shared to applications. And we can also do sharing of video between applications, which is currently used for screencasting. So the typical scenario is that the Wayland compositor that draws the screen captures the video from the screen and then uses PipeWire to send it to the application that implements the network streaming. Now, finally, we need to ensure that we have all the necessary GStreamer features integrated and anything else that may be missing from the Yocto build system and things like that. So that was all from me today. Thank you very much for attending my talk, and I hope to be able to see you all again soon, sometime later this year or next year. Thank you very much.